So yeah, I made a little tool that since there was no agenda, I thought maybe it's nice to show. I can be pretty short about it, hopefully. So this tool is Grasp, and it's kind of a grep for Clojure code, but instead of regular expressions with text, you can use regular expressions in using Clojure.spec. So for those who do not know, are there any people here that don't know what Clojure.spec is? Maybe post a message in the chat. Because I'm not sure if I have to explain that a little bit, but
maybe just it's good to have a very quick introduction about it.
So maybe what is Clojure.spec regular expression? So that is so Clojure has data structures, so you can have like a vector. Can you see my screen, by the way?
Yeah, definitely. Yeah.
So I can make the font even bigger if you want, but I don't know if it's readable.
I think it's good. I think, yeah.
Okay. So you have data structures. So this is a vector with a number and a keyword, for example. And in spec, you can describe these data structures using predicates. So you can say S and then concatenation, or cat for short. And then you have to give it a name, like you say number, int, and keyword, and that's a keyword. So this describes. Thank you. This is a specification, and this describes this data structure. So you can say you can give it a name. So you can say sdef myspec, and okay. So I evaluated it, and now you can say is something valid according to this spec. So you can say, is this valid? Yeah, that's true. But if I say, if I make this a number, and we did expect a keyword here, then it's not valid. So this is false, right? And you can make like text regular expressions. You can make more complicated ones. Like you can say, I want multiple keywords here. So then you can say S plus keyword. So that is more than one or more keywords. So you can say, so now you can say foo bar. So this is also valid, but this is not valid because it's a number followed by two keywords and then a number. So that is not according to the spec. So in normal regular expressions, you would have like something like this, right? A number and then a keyword, I don't know, and then multiple times or something, right? So that is kind of the similarity between text regular expressions and specs. So this is a little overview what you can do with spec. It can do more, but for now that's enough. So on a while ago, 2 weeks ago or something, on Reddit, there was a tool announced that is called Grep. And Grep is a syntax-aware grep for Clojure. And when I saw this, I thought it was very useful because this could solve a problem that I had myself. But it was not so sophisticated that it could detect all the patterns that I was interested in. So because there is another, let's see, I made another project one time to discover patterns in Clojure code where reify is used, and then it spits out all the classes for reify. But this time I wanted to detect patterns in Clojure code where reify is used with more than one class, and that is a little bit hard to do with this pattern because you cannot really distinguish between it only goes so far. So you have like literal symbols and then whatever things, and you cannot like say I want to have a pattern that repeats n times or something. So then I wondered, hey, could I maybe do something like this tool, but then using Clojure.spec because that's way more powerful. So that is what became this tool. So maybe an example. So let's take Clojure core. Let me just paste this in my Emacs. I'll remove this and then paste this. I need to require a bunch of things first. Okay. So this is Clojure's own source code, right? So I just slurped the entire source code from the class path from Clojure itself, or at least the core namespace. And now I define what pattern I'm looking for. So that is the literal symbol reify, and then followed by at least 2 clauses. So this is how I express it. So you say clause and then the clause and then multiple other clauses. So that is more than one, because spec doesn't have a thing for more than one or something. So you just repeat. So you just write one and then one more. Oh, sorry, 2 or more. This is 2 or more. Yeah. So you have at least one and then 1 plus maybe some others. So, and this clause pattern is described by this spec. That is a symbol followed by lists. So in reality, the pattern looks like this. Reify, and then you have some class like objects. And then you say toString. That's a method that you will reify. And then you can have other classes like, I don't know, something like this. Then so this is the pattern that I'm looking for. So I want 2 or more of these reified classes, because I wanted to know how common this pattern was in Clojure, because I'm writing a Clojure interpreter and it didn't support this specific thing yet. Well, it did support it for one class, but not for multiple. So I just wanted to know how common this was in Clojure code. So now this tool can help me express that. So this is my spec. And now I'm going to search in the Clojure code itself for this pattern. Oops. Okay. So maybe I changed the API. I don't know. Let's see. Grasp. It should be there. See what's not working. No such far grasp. Of course. Yeah. Yeah, because I don't know. I'm in this namespace, so maybe that's the problem. So I'll just remove this alias. Let's see, it's here. Oh.
Did you actually compile the namespace yet?
Oh yeah, that's a good. No, I didn't. I think I did. Yeah, I didn't evaluate it all. Yeah, okay. So here it is. So now let's search. So it's a lazy. It returns the lazy sequence of results. So we can count the matches, and it's actually only 2. And we can pretty print the matches. Now you see what it found. So,
Yeah.
so this is what it found. So reify, clojure ID ref, I blocking the ref, I pending. So this is definitely more than one class that is being reified. And it actually found two things, but of course you want to know where it found it. So it has metadata on the matches. You can do meta on the matches. And then you see, oh, it's on line 6974. So let's go to Clojure core. Yeah. Okay, and then 6974. Yeah, and there it is. Here it is, because maybe I'm using a slightly older version of Clojure here, so the line number might be a little bit off. But here, so this is the first one, and the second one is 7107. Let's see, 7107. So that's this one. So that's basically what it can do. It has a couple of nice helper things that let you abbreviate it. Like, I'm not interested in these names. You can use gcat, or rather cat, because I'm in the API namespace already. So you can leave out these names. So it's the same thing. And also if you write normal cat, here you can also leave out, so you can use single, if you want to match on a literal symbol, you can just write the literal symbol with a quote, and then that also works. So if I now do this, oh yeah, now I also need to remove this name. Yeah, I think this is it. Matches. So I have the same matches now. So this is how you can. So I can also rewrite it like this: cat symbol, and then the lists. So that makes it a little bit simpler for searching. It reads a little bit better. So one other challenge that I wanted to solve with this library is, could I also make a binary for this? So you can use it on the command line. And that's what I also did. Let's see.
Maybe can you make the text? Yes, thanks.
Yeah. So let's jump to Clojure's source code again. Or actually, I can just lint my entire, or grasp my entire class path. Grasp. So it first expects a path. So I can just put the entire class path here, and then it will expect a spec. We can just write this here, and this. Hopefully this will work. I'm not sure. And now, yeah. So now it grasps my entire class path for this pattern.
Whoa.
Let's see. So it found quite a lot of things. Clojure core. My library itself. Yeah, I made a copy of spec, so to make it. Yeah, it has spec itself has quite a lot of reify things, so that is why you're seeing it here. So this is, yeah. Let's see. So so maybe make it a little bit. I have Clojure's own source code here. So here you see the same matches as I showed in the REPL, but it also found one in the reducers namespace. So that's, yeah, that's more or less it, I think.
Cool.
Yeah, you can also, you can put these things in a file if you want. So you can also load it from a file, which makes it a little bit nicer to work with than pasting everything on the command line.
Can you just control the output like in Grep to tell me what files are affected, or?
Yeah, I haven't included that yet, so I'm just waiting for more feedback before I'm changing anything.
Of course.
There are, if you want to try out the binary version, so the native version, you can just go to the builds and then click Linux or Mac. And if you go to, then you end up in Circle CI. And here you see the artifacts, so you can just download it there. So it's now 001 snapshot, and there is no officially released binary yet, because I first want to like see where it goes. And
of course.
So, and oh yeah, what's also nice, maybe I have to show that. So so in Clojure you can conform these values, which means that you get back the structure that you so you gave these things names, and if you conform it, then you get the structure back that you described. Let me see if I can show that real quick. Yeah, let's see. So this is the spec again, like we had before. And now I can I have two matches again. And what I mean by, so you can conform, then reify, and then let's pick the first of the matches. So then you get back this structure. So you can say, okay, yeah, okay, this is a symbol reify that matched this name. And then we get multiple clauses. And this is the first clause. And this is my symbol. And these are the other clauses with the symbols. But I'm actually maybe I'm only interested in these symbols and not in the rest, right? So this is where you can use pattern matching libraries for. So I found two that can do this. So Machette, that is the first one. Let me click the link. So it's a pretty simple library. So it's only like one namespace, but it's pretty powerful in what it can do. So you describe like the pattern, and you what you're interested in. You give a name. You started with a question mark, and then you give the data, and then it finds all the matches for you. So here you match this data, and then you get back a lazy sequence of the matches. So I'm only interested in these symbols, so I can give it a name, and then you can. So this exclamation mark is a special notation in this Machette that I'm not sure even how it. Oh yeah, so it's a memo binding. I'm not exactly sure how this all works, but I just asked the author, like, how do I do this for this particular example? And this is what he came up with. So if I then match this on my conformed value, then I get back all these class names. And another library is Meander, which does something similar. So they are pretty similar. So this makes it, maybe I could also integrate this in the command line version, like, oh, here is your spec, and these are the actual things that you want to print as a result. But you can do this in the JVM version. Well, that's more flexible because it's just a library that you can combine with other things. So yeah, that's kind of it.
And can we see how it is done? So that how do you make it happen?
Yeah. Let's see. So I have one API namespace that I was already in right now. So these are only the public functions. So let's just do grasp string, because that just expects a string and a spec and then returns the matches. So let's go into the internals. So what I'm using is, let's see. Oh, this is weird because I'm requiring the same name. So that's probably an oversight. But so what I'm using is.
Can you increase the font a little bit? Sorry.
Yeah, sorry. Yeah. So what I'm using is, let's just start at the bottom. Then that's usually how we do things in Clojure, right?
Yeah.
So let's go. This all has to do with processing files from the class path and from directories and stuff. But this is the real essence of the library, I would say. So grasp string, it gets a string and a spec and some options, optionally. And it uses my interpreter, Clojure interpreter, to parse the code and also to do some lightweight processing. And then I let the interpreter execute this code. And it only will execute namespace forms and top level requires. And I do this so I can also resolve symbols. Like I haven't told that yet, but so let me give an example of why I do this. So if I want to find keywords, like you have maybe you have worked with the reframe library, and what you can do in code is nsfoo and require bar sb, and then in reframe you can say reg event fx b some event or something, right? Now what if I want to find all the keywords bar some event? So if I literally grep on this with a normal grep on this code, I will not find it, right? So you need some intelligence that knows how to resolve these aliases to this keyword. So that is why I'm using my interpreter, because it will evaluate this namespace form, and then it knows that this alias refers to this namespace. And how can I search for this? Let's see. So I have to make a spec that says resolve. Let's see, resolve sim. So it will. Let's see, how does this work again? I have some examples in the README. Let's just go there. Yeah. Okay. Let's do that. Resolve sim. Oh yeah. Okay. So what if I search for the symbol Clojure set difference, right? So I search. You can make a predicate that says, okay, if the thing is a symbol, then I want and then say it's equal to Clojure set difference, but not like the literal symbol, but the resolved symbol, including the alias, taking into account the alias. So this is the result. So this is the literal symbol. And so this is coming from the namespace Clojure set. And but it's also used in Clojure data, for example. But there the symbol is set difference. So this is the literal how it occurs, how you would find it if you, with grep, for example. But this is how you can find it in grasp using some resolve function. So this is basically, let's go back to where I came from. Yeah. So this is why I'm using the resolve. I was actually showing it here. Okay. So this is why I'm using the interpreter. So to resolve namespace aliases, basically.
When you say you execute the top level requires in any parts, does it mean that it actually loads the imported or the required files?
It doesn't.
Pretty much my question is, if I had just a stray Clojure file and I wanted to grep into that, and but the resolve, it won't be able to resolve things, will it break?
No. So you can just grep or grasp all the files. You can throw random files at it, and it will just try to do its best.
Okay.
And it will not load any other files because what I do is I parse the expression from the code, and what I then do is I process if it's a namespace form. I'll increase the font a little bit. So if it's a namespace form, then I process the namespace form. So I rewrite it a little bit, and then I evaluate it. But because I'm using my own interpreter, I can also say what to do if you're loading a file. So that thing is called load fun. And here I just return an empty string, so it will not load any files. So in this load fun hook, if you're using Psi, the interpreter, here this is the function where you will search for the code using your own class path implementation. But here I'm just returning an empty string all the time. So it's not actually executing the requires. So it only processes the requires for to register all these aliases, basically. So it's a little bit of a hack.
Yeah.
And also this is the same thing for the top level requires. So and then normally if you just parse code and you encounter a symbol like this, it has to resolve to something. You cannot just there is no representation that you can parse this thing without resolving the namespace.
Yep.
So, and that's pretty common in the Clojure code. So my interpreter takes care of all of this stuff for you. So that's where the S expressions are parsed, and then it tries to match these S expressions. So let's go there. Match S expression. So that's pretty simple, actually. This is the idea that I also took over from the Grep library, because that library is just using tree seek on the S expressions. So maybe I should demonstrate it. What it does. Let me just copy paste it here and simplify it a little bit. Source trees. Yeah. So what this little function will do is if you paste source trees. So if I have an expression like defen foo plus 1, 2, 3, right? What it will return is the entire expression, but also all individual elements. So def and foo, and then the vector, then plus 1 to 3, but also the individual elements of plus 1 to 3. So this is how and then I apply the spec to all these elements one by one, and if they match, I will return them. That's basically how it works. So that's pretty straightforward.
If you this part is fairly straightforward, but then how to get to that is a bit less, like the resolving of namespace at keywords and things like that. It's less trivial.
Yeah, that's less trivial, but that's actually the stuff that I already had. So so it was just the right mix of ideas this time. Let's see. Yeah. Any questions?
So are you now using it for your own good?
Well, I have, sometimes when I have questions like, well, I wonder where something is used, or does this even, is this pattern common? So it's, for example, today I had, well, in my Clojure interpreter, there was like an edge case that someone was using aliases in protocol functions. So let me explain what that means. So you can write extend protocol and then foo. So this is namespace foo with the protocol.
Mm-hmm.
Then you can do a string, and then you can write foo. But normally you don't write an alias in front of that because you don't have to. So as long as you make clear what protocol you are extending, then you only have to enumerate the methods and not like also the alias. So I didn't know if that was if you try that out in Clojure, you can say def protocol foo, right?
Mm-hmm.
But if I now go to namespace foo and then okay, now I can do extend type string, then user foo, and then I can just do foo or this, and then I don't know, just some imaginary. So if I now call user foo on a string, then it will return the first character. But you can also write this apparently, user foo, like this. And I had never seen this before, but it also works. But it turns out that Clojure just ignores this part.
Okay.
So this is what I needed to fix in my interpreter, but I had never seen that before. So this is when I would use grasp to find, like, does this happen somewhere else maybe in code? And this is pretty hard to find because it depends on this and then some class that's not so important, and then maybe a qualified symbol, and then a list with qualified symbols. So that's that I can express this with Grep. I wanted to.
Indeed.
Yeah.
So you have also extend protocols, so you might have different specs.
Yeah. Right.
And did you find, actually, I'm curious because I also never saw before the syntax.
I have tried it. we can make we can try it real quick maybe.
Mm-hmm.
Like gcat type, and then some symbol, which is the class, and then some qualified symbol, and then a list with another dcat, and then with a qualified symbol, and then whatever, and whatever you can express with this.
Don't you have to put something, because this cat can be like the second function for some reason of the protocol.
Yeah, right.
Sorry, I just don't want to complicate things.
No, but if you use probably if you will use the same qualifier for
Exactly.
the entire, yeah. So now we can just ignore the rest. So you also put this. So I think this is the spec. So sdef, let's give it a name. Like what do we call it? Extend type. And so this is so we can test it out. So let's see if it's valid type. Let's just try it out first, because just to see if it works. So this is false. Okay. Let's see why. So you can do as explain, and it will tell you why. So try that. Oh yeah, it will print it to standard out, I think.
Explain data.
Yeah, let's see if I can. Okay, so garbage failed qualified symbol in 3 at what? In 3 at let's see. So this is why it might be nice to give names, so you can actually debug this. But so sim, then you have to write the elaborate.
Yeah.
So this is the class. This is the let's see,
protocol.
And this let's see, and this is the like the methods and methods, something like this. Let's see if it becomes okay. So it's something in the first method. That's not all right. So we can also give this proper names, like method name and whatever.
Impl, yeah.
As explain. So method name is not a qualified symbol. Well, it is, right?
Can you just print out that quoted list on the rep just to see what it?
Yeah.
If it tries to evaluate anything.
We made a mistake somewhere. Yeah, now I say we because I made a mistake.
We will allow that. We will allow that.
A class symbol, protocols, qualified symbol, method name. It is a qualified symbol, right?
Looks to me like one.
Let's do any and then see if it works. This now it's valid. Success, and you can also do conform. So the method name is
it's the whole thing.
It matches the whole thing. Oh yeah, of course. This is the common mistake. So you have to write spec around this, because else it sees it as one list of things. So you can nest these cat things, and it will just be the one list. But if you have nestings, you have to write s spec around it. Okay. So now it looks better, right?
Yeah.
Okay. So this is also valid.
So you can move back to qualified symbol now. Yeah.
All right. qualified, oops, qualified symbol. So this is valid. Okay, so now we know that our spec is doing what we want. So now we can search RASP string. Well, we can search in Clojure itself, or then it doesn't find anything. So we can also try to grasp our entire class path. System get property Java class path. So this is the entire class path. Now I will try. Let me define these things. Let's see, count. Can take a while maybe. Oh, it found 2. Oh, that's interesting. Let's print them. Oh, yeah, because this is my own code. so okay. Yeah, it found these 2 things now, but it's not in my entire class path. So that's a sign that it's not used a lot. But today I found it for the first time.
Some people are doing it. Okay.
Yeah, someone. Well, I had to make some code compliant with. Someone tried to run it through my interpreter and it didn't work. So this is why I fixed it. So
I see.
So yeah, in these cases, I would use this tool, I think.
I'm just trying to look at your the class path for Grasp, just to understand if it's using anything from the wide.
Not really, but I can maybe. Yeah, I can just do my entire Maven repository.
That might take a while.
I'm not sure if that's recommended, but let's see, maybe a subset, or I don't know.
Metocin, that's
fairly... yeah. Okay, com or org, or I don't know.
Phi, I don't know.
Phi, oh yeah, Phi. Let's go.
Let's just see Mali. What's the
repository, and then Phi. Com Metocin. What is Metocin? What is their just Metocin, I think. What is the library? Mali. Let's see. Yeah, Metocin.
Strange.
No. I have more, or maybe I made a typo then. Repository. Yeah. Oh.
Group ID is Metocin indeed.
Oh, Metocin.
You don't have Mali. Interesting.
Yeah, I did have Mali, but not probably not. Oh, here it is. Well, yeah, Metocin. Okay, we can search in Metocin's libraries for this pattern. Nothing.
Yeah.
Okay, let me just try. No, I won't do the last path. No, don't do it, Michiel. Okay.
Although now I'm curious.
Well, it's lazy, so we. Okay, let's try it. It can take a while.
Yeah, because maybe it's really not used, and yeah.
Yeah, it will scan my entire M2 repository, but well.
Yeah, we should have done this like at the beginning with a future or something, so that maybe by now we would have an answer. But
maybe I could build like a commercial website where you can make a request that searches through mountains of code, and then you get an email when it finds one or something. I don't know. But I'll just stop it now because yeah, I canceled it. So
Okay.
let's see. Cider. For some reason, I have to also always go here, and then it only cancels it. But okay, now it works. So. But probably not that common.
No, I would imagine it's not really that common. No.
Yeah.
And it's even interesting that the actual namespace alias is completely disregarded by Clojure.
Yeah.
Did you by chance address somebody from Clojure Core on that?
Yeah, I asked it in the Clojure Dev channel yesterday,
Mm-hmm.
and I got some explanations. Okay. Like, so this is what the issue that I had, and then Bronza, who knows a lot of stuff about the Clojure reader and analyzer. He wrote tools for that, and he said, I'm not sure, but some macros might generate like namespace stuff, and so that just gets ignored, because if you look at the implementation, then it just does a name on the symbol, so it just looks at this part.
Okay.
Yeah. But these are the types of questions that I would reach for a grasp. Yeah.
Cool.
Yeah. That's it.
But that would be actually nice to have as a tool for your for bigger code bases at least.
Yeah. And what I also find nice is that you can like I have the reframe example here. So what is one limitation? I'm using metadata for the locations. So to find the file name and the line and the column. But not all things in Clojure can support metadata. So keywords do not support metadata. But in reframe, I would like sometimes to find certain keywords. So for example, here I have an alias subs, and I want to find all these keywords. So even if they are used with an alias, right? So what you can do is you say, I want to wrap things that do not support metadata, like in a wrapper. And that wrapper then has the metadata and it contains the thing that was found. But if you do that, you have to unwrap the thing yourself and then compare it to what you actually want to find. And then this way you can also search for things that do not support metadata. So for example, keywords and strings and numbers, stuff like that.
So whenever you say wrap through, every time you are scanning one part of the syntax tree, you're wrapping it into an object, pretty much.
Yeah. Well, not everything, but only the things that do not support metadata. So numbers and strings and keywords, basically. So this is only necessary if you want to find those specific things. So can maybe, yeah, so I can maybe give an example like grasp string, and I want to find the number 1, 200, 5. I want to find the number 100, right? What's this spec first, or see what was the order of things? Grasp. Okay, yeah, the spec is the second one, I think. So now, the options is wrapped through, and if I do the any, then you then it will match anything. So what it will return now is this. So it will return the entire vector, but you see that these numbers are wrapped. Yeah? So it returns the entire vector, but also all the individual elements. So if I want to only match the number 100, and I say unwrap, so function x, and then is 100 unwrap x. So now it will only find the number 100, and I can do map meta on that, and then I have also the location of it. So that's how it works for numbers and keywords. But
Clear.
I think that's kind of an edge case, because I only could imagine, like, for the reframe case, that you want to find certain keywords, and the rest is usually bigger things, like and even symbols support metadata, so it's fairly niche that you will have to do this, I think.
I'm not sure. I mean, to me, one of the first use I would have for this in my own project, I have we are transitioning the domain model to use schema. To use spec.
Yeah.
And I would like to, and we will have to have a big migration, because we did have scattered specs around, but now we are creating a domain spec altogether, and we will have to find everywhere given keyword namespace that keyword is used as a spec, so that we can properly translate. And this is actually a very big use case that I can think of.
Yeah. So the keyword is probably the biggest use case for this wrapped thing.
Yeah.
And but numbers, you can fairly easily find them using normal grep, right? Also string.
Yeah.
So keyword is probably the thing that this is used for.
I see in the code that you are testing for IOBJ instead of IMeta. Any reason for that?
Yeah, let's see. Let's go to Clojure Java. So Clojure has IOBG. Let's see where it is. The alphabet is very hard. Oh, here it is. So these things are, so IOBG are things that support with meta, and IMeta, let's see, support is the thing where you can ask metadata from, right?
It can keep metadata, and with IOBJ you can alter the metadata.
So I need IOBG, I think, because I add this location metadata to it. So if I cannot add metadata to it, then there's no point.
I see. Yeah.
But all these, I'm not sure which things only implement IMeta and not IOBG. But
yeah, I don't know.
I think vars maybe do, because in vars you have to say alter meta, and I don't think you can say with meta. So we can check. So this is aref, and that is probably, yeah, go there. And that a reference. iReference. Oh my god. That has IMeta, yeah, and not IOBG, right?
Yeah.
So yeah, but when I parse Clojure code, there is no thing like a var, or so. It's all lists and symbols and stuff like that. So I'm good. Yeah. So that's why it is like that.
Yeah, it is. Yeah, I didn't know the details of well, that they split something that can hold metadata from something that can change its own metadata into different interfaces.
Same for namespaces. So if I have x1, you can say alter meta x and then assoc private true or something. Alter meta.
Yeah, a source should be a function and private should be a keyword, and so the other way around.
Alter meta. Okay, yeah. Like this. So now x has the metadata private to it, but
Yeah.
you cannot do with meta x private true. That doesn't work because it's not an IOBG. So yeah. Same for namespaces. So yeah. Yeah.
All right. That's actually nice. Okay.
Okay, so if you have any feedback or whatever, let me know. I don't think it's a lot yet, although it has 125 stars. But I haven't received a lot of feedback like, can it do this or can it do that? But if you have any questions, let me know.
Yeah, I think I might. The only thing I might use this for is indeed our main giant domain spec migration, but that's actually useful.
Oh. Yeah, I think the usage of this tool might be a little bit for like advanced patterns that you cannot find with Grep or Grape, the other nice tool. But if you need it, it's actually very handy. So maybe you only need it like once a year or something. But then
you can think of refactoring tools leveraging this Grasp utility.
Yeah, that could also work. Oh. So that's what I have for today.
Cool. Thank you so much. Anybody else has comments, questions?
Could it work with EDN files too? I could imagine someone might want to modify some data in EDN format and
Yeah, I think so. It doesn't really modify anything.
yeah.
But it can find things. So
Mhm.
it can only find things.
Yeah.
So here this is also valid Eden, right? So
Mhm.
yeah, it can find the number 100 in this Eden vector. It could
Yeah.
also be an entire Eden file, for example. Yeah.
Mhm.
Yeah. So you can search like depth Eden files for, I don't know, aliases or I don't know what. Yeah.
Actually, yes, a replace thing would be nice to have.
Yeah. Yeah, so you can compose it with other tools. So you have these locations, and then you can go to these locations and then actually do stuff over there. So I actually have a little other tool that could be useful. It's called Rewrite Eden, and it's built on top of Rewrite Sales JC, which is designed to rewrite code, which is very interesting. So if you're not aware of this, you should check it out. So this is actually in progress because the main rewrite sales.j repository is not really maintained anymore, and there was also a rewrite sales.js version, which is also not really maintained anymore. And now Lee Reed, he from Canada, he he is working on assembling this into one repository called rewrite CLJC. And by the way, I'm also CLJ Condo, the Clojure linter. It's also based on rewrite CLJ. So, but this tool can be used to rewrite things. And I made a little tool on top of this to rewrite Eden files. So you can say, this is a depth Eden file. And for example, I want to add a dependency, but I want to preserve these comments and white spaces and this thing. So normally, if you parse this to Eden, you will lose this and also the ordering of things. But because we're using rewrite CLJ, it parses it to a structure that preserves everything.
Mm.
And now you can say, okay, I have parsed it, nodes. Now I say assoc in nodes, and then depth, my other depth, and then this. And if I then make a string of this again, then you see that everything is preserved, and it added this thing to that. So maybe you could also look into this. Yeah, it's quite sophisticated.
Yeah.
So the heavy lifting is done by the rewrite CLJ library. I just made a thin wrapper here.
And can you the missing link then it would be to go from the line information that you have out of Grasp?
Yeah.
How can you use that information in here? Can you?
Yeah, you can, because this rewrite CLJ library, it has a zipper thing, so you can iterate over all the nodes, and then you can just look at what location the node is. I'm not sure if it also has a way to directly jump to the location, but I'm using it like I described in the first option also here. So this is a project where I'm deleting code. So I have a linter that can detect if something is unused. So you have an unused var, and then it will use the locations that I get from the linter, and then parse that code using rewrite CLJ, and then delete the node at the exact right spot. So I can show that maybe. So it's, let's see, remove. Yeah, so here it loops through the thing, and if, let's see, if the row and the column exactly match, then it removes it. So and that is done using this zipper thing, which is a way to traverse the structures in a very convenient way. So yeah, I think these things could be combined essentially. Yeah.
So this way you could provide, you could still write probably a script or something. I'm not thinking an IDE tool can be easily put together to do some sort of a spec-driven refactoring.
No, I don't think so, because once you're in the specs, then you're doing this in terms of S expressions, which doesn't have the metadata or doesn't have the white space anymore. So if you move things around, yeah, that wouldn't work unless you make these specs not on the S expressions directly, but on the nodes. But that would probably, then you would probably get totally different specs.
Yeah, but and they would be really hard to write potentially as well. But I would say if you were, writing a refactoring at this level, like specifying a spec of the thing you want to rewrite and the shape, the output shape, if you lose comments, tough luck.
Yeah. Okay. I actually I don't use it as a refactoring tool, but clojure also has a hook mechanism where people can rewrite their code like kind of like a macro into something else, and then clojure will lint the something else, and then so this is used to make clojure understand your macros, and it's also in terms of these rewrite clojure nodes. So, and that's just a function.
Okay.
So you could maybe match the code using normal specs, and then provide a function that will receive the nodes and rewrite it into different nodes using the locations that it found. Yeah, I think that would work.
That could work indeed, but it's probably what I would like to be able to do is to leverage the actual match output to do something with it, because then I can decompose the original spec into the components, and then I can pick and choose all of the things and stitch them together in the new shape.
Yeah, I agree with that, but I think you would then end up with like instead of something like this, it would probably become something more elaborate, like oops, function of a node, and then is foobar value node or something, you know. And then it will match the symbol node, and then you can conform it, and then you can do something with that node or something.
Yeah.
But maybe it's not too bad to write it like in terms of this. I could see that become useful as well. But it's a extra level of
Yeah. Indeed. So yeah, but that was just an idea thrown out, and yeah.
Yeah, interesting ideas.
Cool. All right. Any further questions for Michiel?
I think everyone is asleep now.
Your voice is so soothing. No, it's it's late in the evening for many of us, I guess.
By the way, I used the Condo tool, Michiel. In my own code, I enjoyed that, and it helped me to improve my code. So
cool.
Thank you for that.
Nice.
Yeah.
Cool.
Yeah, I'm not going to tell that I'm using CLJ Condo. You know that already, probably. So yeah, just abusing your libraries as much as I can.
Yeah, that's what they're for. So
good.
All
right. Then thank you very much, Michiel. That was a super cool project to showcase, and I'll let you know if I get around to try it out on my big giant project of domain spec refactorings.
Cool.
That might alleviate some pain, hopefully. All right, so we are almost at the 2 hours mark. So I'd say we can actually wrap it up, right? Unless anybody else wants to step up and get the stage for something that's gonna blow our minds. 3, 2, 1. Too late. Maybe next month. So, all right. So that's the end of the Clojure meetup number 131, if I recall correctly. Thanks to everyone for joining us tonight. I hope you enjoyed the evening as I did. We are going to be on air again in December, second Wednesday of December. And the idea is to have a night around the tools from Microsoft Visual Studio Code to do mobile programming or pair programming, sharing code, and being able to collaborate on the same Clojure code base. But more on that next month. For now, again, thank you very much, and bye-bye.
Bye, everyone.
Bye-bye.